Hello everyone, welcome to my channel Civil Softwares. Today we're going to model and solve question number 2 and question number 3 in SAP2000. We have already solved question number 1 in previous video. So let's begin and solve question number 2 and question number 3 today. So at first go to SAP2000, open a new model. Okay, here it comes. So at first we need to check the units. So in our question we have everything in kilonewton and meter. So we need to keep it kilonewton, meter and Celsius. It is okay. So now we are going to define grids. So let's go to grid only. Then we are going to watch the question once again. So here you can see the span of our beam is 2 plus 4 plus 2 is 8 meter. So let's give two grids in x direction 1, 2, which is a 8 meter spacing. So go here, and in x direction we put two grid lines. In y direction we have nothing, so let's just put one, and in z direction let's keep two grid lines. Grid spacing in x direction we have 8 meter span, so we're going to place 8 over here. In y direction it does not matter, in z direction, so it's okay, we are not concerned about this. So let's just click on OK. So we get our two windows like this. So let's go to xz plane so that we can visualize this blue plane over here. Now we're going to add a beam over here like we did in previous video. At first make sure you go to define, go to load patterns, and just keep the self-weight multiplier as 0. Otherwise it is going to automatically add its self-weight and we are not going to get our correct output because we are just analyzing how the load affects the beam. So modify load pattern, so click on OK. So now we are here, we have not defined any sections, we are just analyzing how we can get the model of beam, and we can analyze the shear force diagram and bending moment diagram. So just go to beam. So now we are going to add a beam over here, and here you can see properties of object. So it's okay, section keep as it is, and continuous it's okay. So let's just draw a beam over here from here till here. So we get the beam. After this just click on escape and you get a beam over here. Now what we need to do is we need to assign the restraints. We have hinge support here and roller support here. So let's go and select this point and assign the joint restraints. Let's assign hinge over here, apply. So we get the hinge. Now here we're going to apply roller, apply. Okay, so we are done with giving our joint restraints. Now let's go back to our question and see. So we have 10 kilonewton point load 2 meter from the starting point. So let's just give point loads of 10 kilonewton and 80 kilonewton, which is at the distance of 2 meter and 6 meter from the starting point. So let's go here, let's click on the beam where we need to assign the load. Go to assign, then go to frame loads, go to point load, then we get this window over here, dead load, coordinate system global, gravity, force, it's okay. So now we are going to click on absolute distance, and we are just going to keep 2 meters, and at 2 meters we have 10 kilonewton load. 2 meters we have 10 kilonewton load, and in 6 meter we have 80 kilonewton load. So in 6 meter we have 80 kilonewton load. Now let's just click on apply. So we're going to get 10 kilonewton and 80 kilonewton load here. So now you can see we have uniformly distributed load of 20 kilonewton per meter in between these 2 points. So we're going to assign this uniformly distributed load. So for that, just go to this section, click here, go to assign, go to frame loads, then distributed, Okay, so go to absolute distance. Now what you need to keep over here is at 2 meters. What do we have? We have 20 kilonewton per meter, right? Right. So two from 2 meter till 6 meter. So go to 6 meters and assign 20 over here too. So it's going to give us uniformly distributed load in between these 2 points. So just click on apply. Okay, here what I needed to show is this happens if you do not keep 0 at the 2 distance, because it is going to calculate 0 at 0. So at 0 distance it's going to keep 0 load, and we assign 20 kilonewton per meter at 2 meter. So it's going to give the line like this, right? So what we need to do to solve this problem is we need to just click on 2 and we need to assign 0 over here. Then we need to click apply. So here you cannot apply this because we have not selected the beam. So just select the beam and just keep this. At 2 we have 0. Then starting at 2 we have 20. So in this way it can solve the problem. So click on apply. Okay, is it okay? Now just click on OK, because it is going to replace the previously applied load, because we have checked this replace existing loads. So click on OK. So now you might be thinking, where are the 10 kilonewton and 80 kilonewton load that we just applied, the point loads? So these are has not gone anywhere. You can just check the loads which are acted on any member by doing this. Go to this beam, right click on it, then go to the loads. Here you can see point force 10 kilonewton at 2 meter distance, 80 kilonewton at 6 meter distance, and distributed force we have 20 kilonewton per meter starting from 2 till 6. So everything we have this, right? Okay, so if you need to display 80 kilonewton load and 10 kilonewton load too, just go to display, go to show object load assigns, and just go to frame, then just click apply. So you are going to see every kind of load here: 20 kilonewton, 80 kilonewton, these are our point loads, and 20 kilonewton per meter is our UDL. So it overlapped because it displayed in the same place, right? So have you forgotten anything over here? No. Now let's run this model. Go to run analysis. So we are not going to run this model case, we are just going to run the dead load case, in which we have kept 0 as self weight multiplier. So go to this model and just click on run do not run case. It makes sure that only the dead case is run. So just click on run now. So now we need to save this, right? So give any name, practice, save. So it is analyzing here. You can see the load bar, loading bar. Okay, this is our deformed shape. Okay, you can read this, but for now I'm just clicking on done. Now if you want to see the animation, you can just see just like this. It shows what kind of deflection pattern it has. I'm stopping this. Now we need to see the reaction at the supports, right? So just go on this show forces and stress, go to joints. After you go to joints, just click apply. Then you can see the reaction forces like this, right? You can check if it is correct or not manually too. So if you want the values in tabulated form, you can just go to OK, tabulated, and click on apply. Just like this, you can see the value, but I prefer this arrow because it shows the direction to OK. So now we are concerned about seeing shear force diagram and bending moment diagram. For this, just go in this show forces and stresses, go to frame cable tendons. Now you need to go to shear to see the shear force diagram, apply. Okay, so this is how our shear force diagram looks. Just click on OK. So if you want detail about this, just you can go to this place and just right click on the mouse button. So you can see every detail here. So this is our reaction, this is our point load, this is our uniformly distributed load, right? You can just click here and just see the details about uh, different kind of loads, reactions at whichever point you want. So for shear force you have this diagram, right? And for moment you have this, and for deflection you have this diagram. So you can see, right? So let's just click on done. Okay, in this window we are displaying shear force diagram. So let's go to this window. Now we want to display the moment diagram over here. Go to hit this option, go to frame cable and tendons, then just click on moment 33, just click on apply. Okay, so this is our moment diagram. It's in 3D, right? So just click here, then just right click on it. It will give detail just like we did in this window. Done. This was easy, right? So this is how you can do modeling and just see shear force diagram and bending moment diagram in SAP 2000. So let's just go and solve another question too. So now we are going to solve our third question. So for this, let's just go to our new model, kilonewton, meter and Celsius. It's okay. Now we are going to grid only. In X direction, we are going to give 2 grids. In Y direction, just we're giving 1. In Z direction, we're giving 2. Let's see the grid spacing for X direction. It's 2 plus 1 plus 2 is 5 meters. So just go and click 5 over here. In Y direction, it does not matter, Z, so we are not concerned about it. So let's just click on OK. We get this window. So at first, let's just go on the XZ plane. Now at first we need to go to define, go to load patterns, go to self weight multiplier, and just let's put 0 over here. Modify load pattern. Okay. So now we are just going to draw a beam here. So go here, then let's just keep everything as it is. Go here and just click like this. So it's going to give us a beam. After done, just press escape button. Now we are going to give restraints. Click on this point, go to assign, go to join, restraints, hinge, apply. So we have got the hinge over here. Now here we need to assign the roller, apply. Okay. So now we just need to assign the loads over here. So let's see. Okay, so at first we have 10 kilonewton per meter of uniformly distributed load up to 2 meter distance. So let's go here. Let's select this, go to assign, go to frame loads, then distributed load. Then let's just keep it in absolute distance format and at 0 we have, isn't it 10 kilonewton per meter? Yeah, so 10 kilonewton per meter up to 2 meter distance, right? So up to 2 meter distance it's 10. After it's done you need to keep 0 at 2. Okay, it's okay. Now let's just click on apply. Now let's just click OK. So first task is done. Now another load is 30 kilonewton point load. So go to this section, select it, go to assign, go to frame loads, point load. Then at the distance of 3 meters we have 30 kilonewton load. Yeah, so at the distance of 3 we have 30 kilonewton load. So other thing does not matter to us. Click on apply. So we have got the 30. Click on OK. So let's just see if our UDL is there or not. It is not displayed, but it is there. Right click on this and go to loads. So we have distributed load, right? It is just gone for some time. We can just display it afterwards. Okay, so finally we need to assign this uniformly varying load. For applying the uniformly varying load, we need to assign 0 kilonewton per meter over here and 20 kilonewton per meter over this. So we are going to keep 0 at 3 meter distance and 20 at 5 meter. Okay. Okay, 0 at 3, right? Go to this, go to assign, go to frame loads, go to distributed load. Now okay, so we need to assign 0 at 3, right? So at 3 we have 0, and at 5 we have At 5 we have 20. Okay, at 5 we have 20. Now look at it. If you keep 0 at 2 meter distance, then it is not going to keep our uniformly distributed load, which was up to 2 meter, right? Because at 2 meter distance we have 10 kilonewton per meter. But if we keep 0 at 2 now here, and we have, okay, if it is in add to existing loads, it's okay. But if you have this window in replace existing loads, and you keep the load which is displayed just like this, then our UDL is going to be replaced by this 0 kilonewton per meter. So you need to take care of it. Okay, if you keep 0 over here, then our UDL, which we previously applied, is going to vanish. So if you need to keep on add to existing load, so that the UDL remains, right? So at 3 we have 0, at 5 we have 20, at 2 we have 0, at 0 we have 0. So let's just click on apply. Okay, so you can see both our uniformly distributed load and uniform varying loads over here. Our point load is also there. It is just gone for some time. We can display it again. So let's just click on OK. Okay, so let's go to display. Let's go to show object load assigns. Let's go to frame. Then we're going to show all the loads, right? So click on apply, click on OK. So our task is done here. We have applied all the loads successfully, just like this. Okay, so what we are going to do is we need to run the analysis. So go to run analysis. We're not going to run this model case, so let's just click run now. We need to save the file. Okay, give it any name, practice. Okay, save. Now it shows the loading bar. Okay, it's done. So this is how our shear force and bending moment diagram looks like for this. So if you need to see the deformed shape, you just need to click over here, show deformed shape, right? So we are just applying the dead load case, so it's okay, apply. Okay, so this is our deformed shape. You can just click on animation. Okay, we're just going to keep it like this. Okay, you need to see the reaction, joint reaction. Go to joints, then arrows. Okay, apply. So you can see the reactions over here. Now we want to see the detail about the bending moment diagram and shear force diagram, right? So just go here, go to frame cable and tendons. Okay, for the shear force we have shear 2 to apply. You can see over here, and let's just display. Okay, bending moment diagram, it's already displayed over here. So if you want to see the detail about deflections and all, just click on this beam, right click on it. It is going to show everything about the deflections. It's going to give us the values and everything. Click on done. So in this way you can model any kind of beam and just analyze the bending moment diagram and shear force diagram over here. Okay guys, bye bye, this much for this video. Thank you.